Hi, my name is Frederick Servant. I'm the Arnold Software Development Manager and I'm based in London. If you're not familiar with Arnold, here's a few key points. Arnold was one of the first production path tracers. It scales well for large production scenes and is able to render complex surfaces and materials such as skin, hair, volumes, etc. Arnold is customizable through a powerful API in both C++ and Python. As you know, we now have CPU and GPU rendering, and you can even switch live from one device to the other. It now ships with Maya and Max, and it's the default renderer there. Arnold is also integrated in Houdini, Cinema 4D, Katana, and also in unsupported applications such as Gaffer or Blender. USD stands for Universal Scene Description. It is both a comprehensive framework and a file format to exchange computer graphic scenes and assets. It supports non-destructive workflows with overrides, asset versions, and variations. USD is designed for speed, scalability, and can easily be expanded with your own data and attributes. USD was created by Pixar for their own pipeline at first, and then open sourced in 2016. We've been shipping Arnold with USD support since version 6.02, that was released in February. It's been a labor of love and a top priority for Arnold. At SIGGRAPH last year, we had announced that the Arnold components for USD were being open sourced on GitHub under a very permissive Apache 2 license. While you can compile these components yourself, we ship them in the Arnold Core SDK and our various application plugins, so you can use them out of the box. The development process itself is done openly. Here you can see an ongoing sprint, and you can follow the development work being updated live. The current priority of features and bugs is also available and up for discussion. We encourage you to submit feature requests and report bugs on GitHub. Of course, you are also welcome to contribute and submit pull requests. Let me now give you an overview of the USD components and their integration in Arnold. The simplest way to ingest USD data in Arnold is to use the USD Procedural. It's just another procedural, similar to the Alembic or the AS file format procedurals. What this means is that you can use the workflows that you know and love in any of the applications we support, but with USD data. For example, in Maya, you can introspect the USD content, select items in the viewport or in the render view, and use operators for parameter overrides and assigning shaders. Sébastien will later give you a demo showcasing these workflows in depth. The procedural supports the vast majority of USD shapes. It's important to note that prim vars are translated as user data and thus available in Arnold to drive the shading, for example. While we support the few native USD shaders, this is not enough for production rendering. That's why we also support all the Arnold shaders as USD shade nodes, where the info ID attribute contains the Arnold shader type. We also provide USD extensions to support all the Arnold nodes as USD nodes. USD does not have a concept of operators or a definition for implicit surfaces, for example. You can also set Arnold-specific attributes on native USD shapes, like subdivision iterations on a mesh. They need to be prefixed with the Arnold namespace. In Arnold 6.02, we introduced a new scene file format API. This API allows you to create plugins to define how you load and save an Arnold scene in a custom file format. Now you've guessed it, we have such a plugin for USD. Note that AS, Alembic, and other file formats are also implemented as such. This means that we can now import and export Arnold scenes transparently in USD from any application we support. Moreover, the USD file will contain all the information needed to render with Arnold, including shaders, operators, render options, etc., like an AS file. You can also import and export parts of the scenes, such as shader networks, in USD. Because we have a one-to-one mapping with AS files, we can render USD scenes directly with the Kick command line tool. Contrarily to AS files, because USD can contain an animation, you need to specify which frame you'd like to render. Another important USD component is the Arnold Render Delegate. This render delegate is very important for interactive rendering and easy integration in the applications that support Hydra, such as USD View. Stay tuned for more details about Hydra and see the Arnold Render Delegate in action demonstrated by Paul later in this presentation. Applications that support Hydra and thus the Arnold Render Delegate include Houdini Solaris, NVIDIA Omniverse, demonstrated last year at SIGGRAPH, or Maya USD. Paul will show you way more compelling demos later. But for now, I'm going to hand it over to Sebastian, who will present the USD Procedural and the USD workflow supported today in Arnold.
Hi, I'm Sebastian Ortega, and here I will show how USD can now be used as a scene format for Arnold, meaning that everything that is needed for an Arnold rendering, all the geometries, the lights, the shaders, all the render parameters, everything can now be fully described as USD out of the box. So here I have a Maya scene where the modeling was done, the shading, the lighting. There's a lot of Arnold-specific things in the scene, of course, shaders and lights, but also some Arnold attributes in the geometries and so on. And if I want to save out a USD file with all this data, I have to use the new menus, Arnold, Scene Export, and Export to USD. So either the full scene or selection, we have these options to just export the shaders or just the geometries. And now that's done. I've exported the whole scene to USD. And to show this, I can now open a terminal. So I'm out of Maya here, it's just command line. And I'm going to use the command that we have in Arnold to render standalone files in Arnold, which is called Kick. And if I render directly the USD file, I can see that I have the exact same render with the same settings and nothing is missing. So here the file is fully self-contained. So of course, if I can render this in standalone, it means that I can also bring it in other applications. So for example, here in 3ds Max, I can create a USD node and bring back the file that I just exported, and so that I can reuse it. So this means that we can have assets or shots that we bring from one DCC to another, and we have everything. So not only the geometries that we see here in the viewport, but also if I render, because we now can use the Arnold render view in 3ds Max, we can see that we have also the exact same render. So everything was brought, all the shaders, all the lights, and nothing is missing here. And of course, this also works also in the other DCCs that we support, so Houdini, Katana, and Cinema 4D. Now, if I go back to Maya, I'm going to show how to open USD files, and one of the ways is to use the Arnold stand-in nodes. So it's a proxy node that already existed to load Arnold standalone files, but now we can also directly load a USD file. Here it's the good old kitchen scene. By default, I just see the bounding box, but if I want to load everything, I can show really the geometry, and I can render it. So this is really the original untouched kitchen scene, and I see that it just renders out of the box. And one of the good things with the stand-in is that I can, for example, click in the render view and see both in the viewport and in my list here what I'm selecting, or select the list and see it in the viewports. So I can really see exactly all the contents of the USD file, but most of all, I can do overrides or do my look dev. So here I say that I want to assign a shader. I bring, for example, a car paint on the table and the chairs, and so on. I can do my whole look dev. So for example, I select the floor. I'm going to bring back, for example, a chrome shader. So I assign a new shader. I select standard surface. Here it is, and I can bring back a preset from the presets list, chrome, and now I have a chrome shaded floor. So we can use it to do all the shading. We can assign also displacement with this UI, but we can do a lot of different overrides. You can override all these attributes, which are the Arnold attributes for the meshes, the subdivision. We can hide objects, for example, if I select the fridge here, and here it is, and I assign the disable node here, the fridge is gone. I can also move objects if I want to. So for example here, the chair, I assign a set transform node, and I can apply a translation, so that's on one of the chairs. Here we go. So I can do a lot of overrides, and if I click on the show graph button here, I can see that this has created several nodes that were attached to my stand-ins. And these nodes are operators. So operators in Arnold are a powerful way to really apply overrides at render time. And it can be anything. We can assign shaders. Here I can enable and disable my transform operator that moves the chair. We can do a lot of different things. And we can also create several versions, so several looks. So here I'm creating a new look that I'm going to call props, for example. It's fresh new look, so I don't have any of the previous overrides, and I'm going to select everything except the props, and I'm going to disable it. So now I just see here the props, and I can switch between one or the other of the looks. And all this is again saved as operators attached to my stand-in. And what is interesting here is that, of course, these operators can be brought back from one asset to another, one shot to another, or even from one application to another. So I could reload these operators from another application. I can use the menu export operator graphs, and these operators can be saved as USD. So here I'm saving this. I'm enabling this option here. That means that I want to also bring all these new shaders that are created in the USD file, and that's done. Now I have created a file with all my look dev inside. So if I reopen a fresh new kitchen scene, the same as before, it doesn't have anything of what I've done before, but I'm going to reapply the same look dev with this USD file. So if I go back to the menu operators, import operator graph, I'm going to choose the same USD file that I had before, and this has imported all my operators. So if I open them in the node editor, for example, I see that everything is there. And by just connecting it back to my stand-in, I'm going to reapply exactly the same look dev. And this is really a powerful way to, for example, share the same look dev across different assets, or to bring them from one shot to another, or at the lighting stage if you have last-minute changes that you want to apply as overrides on a scene. And what's interesting here is that everything was fully done relying on USD. I have a stand-in loading a USD file. It could be a file exported with the menus I showed before, and then I have several overrides that were also brought with a USD file. So it means that it would work exactly the same way, going from one application to another, from Maya to Max to Houdini to Cinema 4D or Katana. I would always have the exact same render. So there's another way to load a USD file in Maya if you have the plugin Maya USD, that is also open source on GitHub, which is using the USD proxy shape. So if I load Maya USD, I have this new menu, USD stage from file, and I can load the same file that we've exported before that had all this Arnold data inside. And so I can see here the geometries in the viewport, but what is really interesting is that if I render in Arnold, it just renders out of the box, even with all the Arnold shaders and lights that are not built in Maya, or not even built in USD. But still, if I load in the proxy shape and render in Arnold, I can see that it just renders, and I see all the Arnold nodes that are here, part of the USD file. And in Maya USD, there's also another plugin called M2H, Maya to Hydra, which allows to enable a Hydra viewer in the Maya viewport. So far, all that I've shown is released with Arnold and works out of the box. But there are several other modules in the Arnold USD open source repository on GitHub that, even though they're not released yet, they can already be compiled by the users. So for example, we have the Arnold schemas, we have the discovery plugins, and we also have the render delegate, which is meant precisely for Hydra. So if you have loaded M2H, you can switch the viewport to show Hydra in GL by default. And as I've done, you have compiled the Arnold render delegate module, you'll be able to render it in Arnold too. So here again, I have an Arnold rendering, I have the Arnold shaders and lights, but now this is going through the Hydra framework. So as I say, this is not released yet in the Maya plugin, but it has been released already in Houdini in several versions for Solaris, and this is shipped out of the box. So now I'm going to let Paul explain more in detail the Hydra framework.
Hi, I'm Parmezei, and I'm going to talk about interactive rendering using the Arnold render delegate. Let's begin with a very high-level overview. USD, the Universal Scene Description repository from Pixar, is not a single entity but a collection of libraries and utilities with each covering a large topic. We have Base, which takes care of common tasks like math operations, loading dynamic libraries, or multi-threading. Next, we have USD that takes care of scene composition, defining schemas, and provides a large selection of ready-to-use schemas. Next is Hydra, which focuses on rendering and offers a base set of OpenGL, Metal, and other GPU interrupt functions. We also have USD Imaging, which builds on Hydra and gives us a Hydra scene delegate, OpenGL shaders, USD View, USD Record, and many others. Today I'm focusing on Hydra. Hydra is a library that connects a scene delegate to a render delegate and produces images. It uses this scene delegate to generate a scene description for rendering. This could mean reading data from a USD file or host application directly, like Maya or Houdini. Then Hydra feeds the scene description to a render delegate, like the Arnold one. The render delegate interprets the scene and uses the underlying renderer to calculate and return pixel data. AOVs like color, depth, primitive IDs, or light path expressions. There are some other tools used to make this possible, for example, the node registry, which tells Hydra what shaders are available. We provide a render delegate and a node registry plugin in Arnold USD. The render delegate is using the Arnold core to render the Hydra scene description and return the AOVs requested. The node registry plugin generates a set of shader definitions, each representing an Arnold shader, containing the default parameter values and metadatas. A great example of using Hydra is Solaris, Houdini's Lightning a scene assembly tool based on USD. Solaris recognizes our render delegate and the node registry plugin from H2A, so it can compose Arnold renders over the OpenGL viewport. We can import the USD file from Maya and see the same results as in the previous presentation. The viewport remains highly interactive and performance is comparable to the Arnold render view. Instead of operators, we can use USD native workflows to modify and interact with the scene. For example, transforming objects like moving the helmet, creating and assigning materials like using a utility shader, or applying Arnold render attributes to objects like making parts of the body invisible to camera and shadow rays. Feedback of every change is immediately visible thanks to the fine-grained update information Hydra provides, and we can quickly switch between different representations of the same scene. Rendering is continuous because the Arnold universe is never shut down, so there is minimal downtime when making changes. We can also configure and preview Arnold AOVs using USD native primitives like the render var, the render product, and the render settings. AOVs works just like in other Arnold plugins. Built-in AOVs like color and diffuse direct, light path expressions, or displaying render vars like UV coordinates. Again, everything is interactive, so I can change any AOV on the fly. USD and Solaris also supports the display of skin meshes, allowing the efficient representation of crowds. Here we import one of the example crowds and switch between frames of animation. While we already provide a plugin, Houdini to Arnold, that allows us to do interactive renders, the real power of Hydra that it lets us to target multiple applications using the same code. We don't have to deal with application-specific APIs, scene representations, or callback behavior. We support how USD and Hydra represents data, and that is uniform across multiple host applications like Houdini, Katana, or Maya. For example, here I'm using Katana's Hydra viewport and the Arnold render delegate to render the scene interactively. We get the same performance and interactivity as in Houdini. Selections and drawing over the Arnold rendered image works out of the box, because the render delegate provides per pixel primitive ID and normalized depth. We didn't add any Katana specific code, just compiled the render delegate using the USD headers and libraries included in Katana. In the past, to support features like this, we had to deal with an application specific API, something that can get complicated quickly. Here we just follow the Hydra conventions and the rest is taken care of. Next, we are taking a quick look at USD view. We can open the file exported from Houdini and render using HD Store or streaming OpenG render delegate or switch to Arnold. As you can see, the materials are different between the two render engines. This happens because USD and Hydra supports specializing shaders for renderers. With this, we can use a single material for both preview and final renders. Another game-changer feature of USD that is designed to store multiple variants of the scene in a single file and only load what is required. In this example, we can change between variants of the stage. One of them is what shader are assigned to our meshes, one for quick ambient occlusion renders, one for final renders, and one for object ID preview. We can also use variants to switch between different lightings interactively, like a skydome light or two distant lights. Here, the lightings are not part of the scene, but we are switching between referencing two external USD files. This approach can be extended to store a shot in a single file, switching between different versions of animation, shaders, lightings, or effects with ease. This approach is highly scalable, so we can selectively access the data to compose the scene at any time.
Thank you, Paul. This concludes our tour of USD in Arnold, and I'd like to talk a little bit about what's next. If you browse the tickets on GitHub, you'll see that there's still a lot to do. This is a tentative list of the issues we are thinking of addressing next. And this is where we need your help with development priorities. If you are an Arnold customer and are interested in deploying Arnold and USD in production, we'd like to hear from you. Tell us what is blocking, what is not working, what you require for your USD pipeline. And this is exactly what we have been doing with these studios, and it's incredibly helpful. So big thanks to Luma, Rodeo, Superprod, Viston, Megalis, and Skydance. I'd also like to thank Pixar for creating USD, Side Effects, Otoy, and the Foundry. We've managed to collaborate in good spirits, and our common customers and the whole industry are benefiting from it. Thank you.